We focus on the cerebellum, and it's this part of the brain that contains 80% of all the neurons in the brain, but it's small, it's in the back, it's actually Greek for small brain. And historically, it's been known to be responsible for motor coordination. But we know that the cerebellum is highly involved in social interaction, in cognitive function. We sit right at this overlap between motor impairment and cognitive impairment. 80% of people with autism have some kind of motor impairment, and about 50% of patients with ADHD have some kind of motor impairment. So there's this Venn diagram, and we sit right in the middle to kind of understand how is the cerebellum involved in the motor impairment in these cognitive disorders, but also is it contributing to the cognitive aspects of these disorders as well. The bread and butter of our lab is electrophysiology, and so with that, we can actually record neuronal function. We have it on different levels. We can do electrophysiology in cell culture and say, okay, in a dish, what is this channel doing to this cell? We can do it in an intact brain and say, in a system, what is this mutation doing to this system, to the function of multiple cells, to the function of a cell in a brain? And so we're kind of going back and forth with that to compare. We have models of many of these mutations, and so what we can do with those models is we can record the neurons in those models. And so we use electrophysiology to record the function in health, but also record the function in a disease state and say, how do these mutations mess up this system? And then can we fix it by adding drugs? Can we fix it by manipulating this specific channel or channels that it interacts with? We also have a branch of my lab that is doing electrophysiology specifically in single cells. And so with that, we can add the DNA from these mutations, and we can say, how does it change the function of the channel? So increase, decrease in the channel function, and how is it changing the expression of the channel? And so we kind of have this holistic way of looking at these mutations in multiple different ways. Really, our goal is to help patients, and that's kind of my driving light. I interact with patients all the time, and so seeing them and seeing their passion, you just kind of want to get back into the lab and say, okay, I'm going to figure this out for you. Generally, what patients, they just kind of throw drugs at them because they're treating symptoms. And so what we really want to do is go down to the core. We're going to go down to the mechanism behind these symptoms so we can actually treat the cause. And so what we're hoping is we can find a common mechanism that can alleviate the motor and alleviate some of the cognitive symptoms so these patients don't have to be on a laundry list of drugs. So we're really interested in understanding that, but also really interested in developing therapeutics based on the pharmacology and the recordings that we do to help fast track this to get it to patients.